Now welcome to the next session. We discuss classroom workbook from question number 21 onwards. So let us start the session with question number 21. The variance of a random variable x, with a PDF P of x equal to half into mod x into e power minus mod x is blank. So here PDF is given. We need to find the variance of this random variable. So ultimately when the PDF is given as a function of x, this must be CRB. So here x is a continuous random variable. We need to find its variance. So what is the formula for variance? Sigma x square is e of x square minus e of x whole square. So at first let us find mean value. So here e of x is integral minus infinity to plus infinity x into p of x dx. So this is integral minus infinity to plus infinity x into half into mod x into e power minus mod x dx. Now we are integrating this function between the limits minus a to plus a. Now when you look at this overall function, this is an odd function, because replace x by minus x, mod x modulus of minus x is same. So there are no changes only for p of x. But when you replace x by minus x for this function, suppose you call it as this function as h of x, overall function. Then when you replace x by minus x, you will get minus h of x. So h of minus x is minus h of x. Therefore this h of x is an odd function. This is an odd function. So when you integrate odd function between the limits of minus a to plus a, what is its value? The value is 0. When you integrate an odd function between the limits minus a to plus a, the result will be 0. So uniform mean value will be 0. Now let us find e of x square. So this is integral minus infinity to plus infinity x square into p of x dx. So this is integral minus infinity to plus infinity x square into p of x is half mod x into e power minus mod x dx. Now this overall function is an even function. This is an even function. Suppose you call it as h of x. When you replace x by minus x in the new function, h of minus x becomes h of x, because even power is there, modulus is there. Mod x is even function, x square is even function, product of even functions is even function. Therefore this is an even function. So when you integrate even function between the limits minus a to plus a, the result becomes like this. Let me write out the result. Integral minus a to plus a f of x dx equal to 2 times integral 0 to a f of x dx if f of x is even function. If f of x is even. So minus a to plus a. According to this becomes 2 times integral 0 to infinity. So limits are converted to positive limits. So when you consider x-axis, the limits are ranging from minus infinity to plus infinity. But origin is located at this. So x is moving towards positive side. Limits of x are positive. When x limits are positive, this mod x becomes x. Therefore this is 2 times x square into half into this mod x becomes x, like this. Therefore this 2 and this 2 gets cancelled. This is integral 0 to infinity e power minus x into x cube dx. Therefore this is integral 0 to infinity e power minus x into x power 4 minus 1 dx. Now this is a gamma function. Here n value is 4. So this is gamma of 4. Gamma of 4 is 3 factorial. Therefore this is 6. So e of x square value is 6 and this is anyhow 0. Therefore variance of this random variable is 6. Now we have applied concepts of differential calculus. That means when you integrate an even function between minus a to plus a, it will be 2 times integral 0 to a f of x dx. Similarly, when you integrate odd function between minus a to plus a, the result will be 0. So we have used both the results. When you integrate an even function between minus a to plus a, we have one result. When you integrate odd function between minus a to plus a, the result will be 0. And then we have applied the concept of gamma function. So this is a gamma function, but here the value of n is 4. So this is gamma of 4. Gamma of 4 is 3 factorial because gamma of n is n minus 1 factorial. Gamma of n is n minus 1 factorial. So therefore, according to this, it will be 6. Anyhow, this mean value is 0, E of x square is 6. So the value of variance is 6. This is my final answer. Note these points. So the difference between number of heads and number of tails is n minus 3 is. How many times coin is tossed? N times. So look at options because we can get this answer easily from options. So option A is 2 minus n. B, it is 0. C, it is 2 minus n plus 3. D, it is nc n minus 3 into 2 minus n. So the difference between number of heads and number of tails must be n minus 3. How many times coin is tossed? Exactly n times. So coin is tossed n times. Now suppose if n is 3 or if n is at least 3. Suppose n times means I may toss my wish. I may toss a coin 1 time or 2 times or 7 times or 100 times. Suppose if n value you can take 3 value or any value from 3 onwards. Then 2 minus greater than or equal to 3, it will be negative. Probability should not be negative. Therefore, when you take n value 3 or from 3 onwards, this will be negative probability. So there is no chance. Similarly here also, suppose if I take n value, for example, this is 6. Now in that case, this is 5 minus 6, you will get negative probability. So no chance. So in here also, when you take n value negative, 2 minus n is negative. So no chance. For example, if I take n value 3 here, so we were getting negative probability in this case. Negative probability. So no chance to get option D. If n equal to 6, this will be negative probability. If n is 3, it leads to negative probability. If n is 3, it gives negative probability. If n is 6, it gives negative probability. If n is 3, it gives negative probability. Because a coin is tossed n times means I can toss a coin any number of times. So if n equal to 3, this will be negative. If n is 6, it will be negative. If n is 3, this will be negative. So ultimately B will be right answer. Suppose if you don't get this idea, work out this. So how many times coin is tossed? N times. Let us have a table. So number of heads, number of tails, and the difference column. So this is the number of heads, number of tails, and difference. So assume that all heads are n. Coin is tossed n times, all outcomes are heads. In that case, number of tails is 0. So difference is n. Suppose I will decrease head count by increasing tail count. I will write all possibilities. So number of heads is n minus 1. That means number of tails is 1. So if a coin is tossed 7 times, suppose 6 heads, that means 1 tail. So I am decreasing head count by increasing tail count. That is my strategy. So what is the difference between these two? This is n minus 2. Next, number of heads is n minus 2. Number of tails, in that case, n minus 2. This is difference is n minus 4. Suppose this is n minus 3. This will be 3. It is n minus 6. So when you continue the table like this, suppose if it is 3, then this becomes what? This is n minus 3. So 3 times heads, remaining times you will get tails. So here the difference is 6 minus n. Suppose this is 2. So this is n minus 2. Then this becomes the difference is 4 minus n. If it is 1, so it is n minus 1. The difference is 2 minus n. If we have 0 heads, that means all tails, the difference is minus n. Now when you look at the difference table, when you look at the entire difference table, there is no n minus 3. No n minus 3. So that means there is no chance to get n minus 3 as the difference between number of heads and number of tails. Therefore, the required probability is 0 divided by coin is tossed n times. The total number of sample points is 2 power n. So the required probability is 0. Okay. So note these points. 3. Let x be a random variable which is uniformly chosen from the set of odd positive integers less than 100. What is my x? It's a random variable which is uniformly chosen from the set of odd positive integers less than 100. Then the expectation of x is. So how many sample points will be there? X is a random variable which is taking odd positive integers less than 100, 1 to 100. So 1 to 100, how many odd positive numbers will be there? Only 50. So the random variable x is taking finitely many sample points, so it's a discrete random variable. When something is a discrete random variable, you can easily find its expectation, right? Now let us have the PDF for this random variable x. So here x values are 1, 3, 5, 7 and so on 99. Now let us have the probability. So how many sample points are there? 50 sample points. So actually my sample space is like this. S equal to 1, 3, 5, 7 and so on 99. So how many odd numbers are there inside S? Only 50. So 50 odd numbers, 50 even numbers up to 100. So below 100, how many odd numbers are there? 50. So x is a random variable which is uniformly chosen from the set of odd numbers, odd positive numbers below 100. So what is its probability? You select one from this. So we have 50 elements inside this. So the probability to get 1 is 1 by 50. The probability to get 3 is 1 by 50. Similarly, for all sample points, the probabilities are 1 by 50 each. Now this is the PDF of this random variable x. Now let us calculate E of x value. Expectation 1 into 1 by 50 plus 3 into 1 by 50 plus and so on plus 99 into 1 by 50. Now we can take 1 by 50 common. This is 1 plus 3 plus 5 plus and so on plus 99. So what is the sum of first 50 numbers? We have some result. The sum of first 50 numbers, let us see. See, suppose if I have 1 equal to 1. 1 plus 3, this is equal to 4. So 2 square. 1 plus 3 plus 5. Sum of first 3 odd numbers, this is 9, 3 square. So therefore this quantity is 1 by 50 into sum of first 50 odd numbers is 50 square. So this gives 50. Sum of first 3 numbers is 9. Similarly, when you take, suppose sum of first 4 odd numbers, 1 plus 3 plus 5 plus 7, this is 16. Basically this 16 is 4 square. Therefore when you consider only 1, it is giving 1. Sum of 1 and 3, 4, this is 2 square. 1 plus 3 plus 5, sum of first 3 odd numbers, it is 9, but 9 is 3 square. This 3 represents how many odd numbers are there. Count is important, but they must be first 3 odd numbers. 1 plus 3 plus 5 plus 7, this is 16. Sum of first 4 odd numbers is 4 square. Similarly, the sum of first 50 odd numbers is 50 square. So 1 by 50 into 50 square, the answer is 50. So this is the PDF and this is its expectation. Consider a die with the property that the probability of a face with n dots is proportional to n. So we have a die with n faces. A die with the property that the probability of a face with n dots is proportional to n. So generally when you take a die, we have 6 faces. On one face you have single dot. On one face 2 dots. So at the last it has 6 dots. Okay. So the probability of a face with n dots is proportional to n. So this is the given. Probability of a face with n dots is proportional to n. So here proportionality means 2 proportionalities will be there. One is directly proportional, another is inversely proportional, but this is directly proportional. So the probability of a face with 3 dots showing up. So that means we need to find P of 3. So generally when this property is not given, when this condition is not given, what is P of 3? 1 by 6, 1 out of 6. But here this condition is given, let us see. So here P of n equal to k into n. So therefore here P of 1 equal to k, P of 2 equal to 2k, P of 3 equal to 3k, So therefore P of 4 equal to 4k, P of 5 equal to 5k, P of 6 equal to 6k. That means the PDF is given like this. So random variable x takes 6 spaces, 1, 2, 3, 4, 5, 6. The probabilities will be like this. So this is k, 2k, 3k, 4k, 5k, 6k. So we need to find P of 3. But what is this P of 3? This is 3k. So if I know k, I will get P of 3 directly. Sum of all probabilities must be 1. Therefore k plus 2k plus 3k plus 4k plus 5k plus 6k equal to 1. Because it is a discrete random variable, sum of all probabilities must be equal to 1. All probabilities are k, 2k, 3k and so on 6k. So this is 21k equal to 1. Therefore k equal to 1 by 21. Therefore this P of 3 equal to 3 into 1 by 21. So this is 1 by 7. If this restriction is not given, then its probability becomes 1 by 6. There is some condition, so the probability becomes 1 by 7. That means less chances. Because previously 1 by 6, now it is 1 by 7. Therefore, there is a less chance to get probability of getting 3 when this condition is given. Okay, note these points. An examination paper has 150 multiple choice questions of 1 mark each, with question having 4 choices. So how many multiple choice questions are there? 150. Each weightage is 1 mark. So each is having 4 choices, A, B, C, D. Each incorrect answer gives minus 0.25 marks, negative marking, 1 by 4 negative. For wrong answer, you will get 1 by 4 negative marking. And for each correct answer, you will get 1 mark, right? That is very clear. Suppose 1000 students choose all their answers randomly with uniform probability. So it's a random, just like throwing a stone, right? So therefore, suppose 1000 students choose all their answers randomly with uniform probability. So the sum total of expected marks obtained by all these students is. Now this is very interesting question. It is related to expectation. Of course, it is related to student side, right? Your side. So the students are opting options very randomly with uniform probability. So there is no logic involved in that. So what is the sum total expected marks obtained by all the students? So how many students are there? 100 students are there. 100 students are there. How many options? 4 options are there. Each incorrect answer gives minus 0.25 marks and correct answer gives 1 mark. Correct answer gives 1 mark. Each incorrect answer gives minus 0.25. So they were asking sum total expected marks. So generally expected means expectation. Expectations are possible for random variables. So let us store the marks of one student inside a random variable. So here assume that x is a random variable which represents marks of one student. Here x represents marks of one student for attempting single question. Let x be a random variable. X be a random variable which represents marks of a single student for attempting single question. Therefore, the PDF looks like this. The probability distribution function will be like this. X values are, so they will get 1 mark, right? And minus 0.25. So marks will be like this. So if student wants to get exactly 1 mark, he has to write exactly one option out of 4. So therefore, he or she has to choose exactly correct option out of 4 choices. But to get negative mark, out of 4 options, they may select 3 remaining options. So 3 by 4. So this is the PDF of a random variable x. Let me explain very clearly. Here they were asking sum total expected marks obtained by all these students. The number of questions is 150. Number of students are 1000. But let us take there is only one student attempting single question. After that, I can apply for 150 students and for 1000 number of questions, right? 1000 number of students, 150 questions and 1000 students. So here we have like this. So it is 4 options. Each incorrect answer gives minus 0.25 marks. Basically, this is not 100, 150 multiple choice questions. So it is 150 multiple choice questions. Each is having 4 choices. Each incorrect answer gives minus 0.25, 1 by 4 negative. But if you attempt correctly, you will get 1 mark. So the sum total expected marks obtained by all the students. The number of questions is 150 questions. Number of students are 1000. So we have 1000 students. So since they were asking sum total expected marks, so assume that x is a random variable which represents marks of a single student for attempting single question. Therefore, the PDF will be like this. So therefore, the student may get 1 mark. So when student gets 1 mark, if he or she attempts correct option. So 1 out of 4, because out of 4 only 1 will be right. So out of 4 remaining 3 will be wrong. If a student attempts any one of the 3 wrong options, he or she gets minus 0.25 marks. So this is PDF. Now what is expectation? E of x equal to 1 into 1 by 4 plus minus 0.25 into 3 by 4. So therefore this is 1 by 4 minus this is 3 by 16. So LCM is 16, this is 1 minus. So therefore this is 1 by 4, 3 by 16, LCM 16. This will be 4 minus 3. So this is 1 by 16. But the general sum total expected marks, is equal to, this is expectation only for single student for attempting single question. But how many students are there? 1000 students. How many questions? 150. So therefore this is 1000 into 150 into 1 by 16. When you simplify this, you will get 9375. Therefore option number D is right answer. Option D is right answer. So note these points. I will tell you about this X. Let X be a random variable. Let capital X be a random variable. Let X be a random variable which represents, X be a random variable represents marks of one student for attempting one question. Let X be a random variable represents marks of one student for attempting one question. Therefore, the PDF is this. Have this tabular form. E of X is this. Therefore, the sum total expected marks is this. Option D is right answer. Discuss question number 26. Let S be a sample space and A comma B be two mutually exclusive events such that A union B equal to S. Then the maximum value of P of A dot P of B is blank. The maximum value of P of A dot P of B is blank. Now look at this. Here S is a sample space such that A union B equal to S, where A and B are mutually exclusive. Mutually exclusive means what? If an event repeats in A, that should not be repeated in B. So A and B are disjoint. That means A intersection B is pi. There is no common sample point for A as well as B. Now A union B is S. So apply probability on both sides. P of A union B equal to P of S. This implies P of A plus P of B minus P of A intersection B equal to P of S. Now you can see A and B are mutually exclusive. That means if A occurs, then B cannot occur. If B occurs, then A cannot occur. In that case, what is its probability? Its probability is 0. A and B are mutually exclusive. So apply probability on both sides. P of A union B is P of S. So this is P of A plus P of B minus P of A intersection B. In case of mutually exclusive events, P of A intersection B becomes 0. Because what is the definition of exclusive? If A occurs, then B cannot occur and vice versa. So therefore A and B cannot occur at a time. So probability is 0. Therefore this is P of A plus P of B equal to probability of whole sample space is 1. Because all sample points will be covered. Probability of S is total number of sample points divided by total number of sample points. It is 1. So let assume that X equal to, for example, P of A. Therefore, in this case, P of B becomes 1 minus X. Therefore, P of A dot P of B equal to X into 1 minus X. Now we need to find maximum value of this. So assume that this is f of x. So let f of x equal to x into 1 minus x. But basically this x into 1 minus x is P of A dot P of B. I need to find the maximum value of this. So this is a function in the single variable. Now I need to find its maximum value. Let us apply maximum minimum concept of functions of single variable. So how to get maximum value of this function? At first we try to find stationary points. F dash of x is 0. Basically this is x minus x square. So f dash of x is 0 to get the stationary point. So it is 1 minus 2x equal to 0. Therefore x equal to 1 by 2 is a stationary point. Now what is f double dash x? Second derivative of this is minus 2. So therefore f double dash of 1 by 2 equal to minus 2. This is negative. Therefore f of x has maximum at x equal to 1 by 2. Therefore maximum value of f of x equal to f of 1 by 2. So replace x by 1 by 2. You will get 1 by 2 into 1 by 2 minus 1 by 2 into 1 minus 1 by 2. So this is 1 by 4. Therefore this is 0.25. Therefore we have applied the concept of maxima and minima are functions of single variable. Okay, note all these points. Number 27. Each of the 9 words of a sentence. What is the sentence? The quick brown fox. The quick brown fox jumps over the lazy dog. So each of the 9 words, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have totally 9 words. So each of the 9 words in the sentence is written on a separate piece of paper. These 9 pieces of a paper are kept in a box. One of the pieces is drawn at random from the box. The expected length of the word. Expected length. So generally expectations are possible for random variables. So let us store length of a string, length of a word inside a random variable. So here x is a random variable which represents the length of a word. Now let us see expectation values. So what are the possible lengths? Let us see. So here least length is 3. One word, second word, and third word, and this is fourth word. Out of 9 words, there are 3 words of length 3. Okay. Next length 4, over and lazy. So we have exactly 2 things. Okay. So of length 4. Now length 5, quick, brown, jumps. So length 5 is there. Let us look at the probability. So how many words are there of length 3? 1. This is 2, and this one is 3, 4. So 4 out of 9 words. Length 4, over Lazy, only 2. 2 out of 9. Length 5, quick, brown and jumps. So 3 by 3 by 9. So this is the PDF in case of this random variable. So let us find its expectation. So the expectation is 3 into 4 by 9 plus 4 into 2 by 9 plus 5 into 3 by 9. So therefore this is 1 by 9, you can take common. This is 12 plus 8 plus 15. So this is 35 divided by 9. It is close to 4. This is approximately 3.88. If it is 36, it will be 4. It is slightly less than 4. So 3.88. So note this. Here x is a random variable which represents length of a word. So have this PDF and evaluate this expectation.